Hi, my name is Nityananda for nithya.org. Today we are going to see Kubernetes as a deep dive. In this series, I am going to present multiple parts which to build fault tolerant and resilient container cluster. In this video, we are going to see what is Kubernetes and their ecosystems, how it is functioning. All things we are going to see in this video. If you want to access the source code, you can go www.github.com/nithyananda/kubex, and also I am inviting you to visit my website nithya.org or nithya.io. First of all, what is Kubernetes? A Kubernetes is nothing but an open source platform for automating deployment, scaling, and operations of application containers across cluster of hosts, providing container-centric infrastructure. With Kubernetes, you're able to quickly and effectively respond to the customer demand. How it is possible? Because it's allowing to deploy your applications quickly and predictably, and scale your applications on the fly across the clusters, and seamlessly roll out any new features which you are developing, and optimize use of your hardware by using only the resource you need. And also definitely it is portable, extensible, and self-healing. Because the portable means you can run the Kubernetes cluster across using public cloud or private cloud, even hybrid and multi-cloud. How it is extensible? Because you can put anything as a modular and pluggable and hookable and composable components inside the cluster. And it's allow us auto placement, auto restore as a self-healing mechanism. What are the benefits which Kubernetes provides? The first benefits which I am seeing is agile application creation and deployment. You can easily create a container image compared to the image use. And also, it supports easy continuous development and deployment integration because it's provide reliable and frequent container image build and also deployment with quick and easily rollbacks because all the images are mutable as Dockers. And also its awesomely supports for DevOps operations. It creates application container images at build and release time rather than deployment time, thereby decoupling application from infrastructure side. The next one is it maintains the consistency across the environment. Maybe a testing or production. You don't require to worry about, hey, my application works only on development, but it's not working on production and testing environment. It may be, but Kubernetes is awesomely giving the environmental consistency across the clusters and environment. And it supports distribution portability across cloud and OS. It runs on Ubuntu, RHEL, CoreOS, and on-prem or Google Control Engine, even AWS or anywhere else. And it also supports application-centric management because it's raised the level of abstraction from running an OS on virtual hardware to running an application on OS using logical resources instead of only depends on hardware. And it's very loosely coupled, distributed and elastic and liberated microservices. You don't require to create a monolithic application like a legacies because Kubernetes firmly supports applications are broken into smaller independent pieces and can be deployed and managed dynamically. And it supports awesomely for resource isolation and also provides a predictable application performance. As I said, it's maintain the resource utilizations at optimum level. It's not going to take the chunk of hardware from you. It's only maintained that it only takes whatever the hardware it needs to run So it provides high efficiency and density. And what it does provide to us, what it can do, it's doing many purposes. The first and the most benefits is co-locating helper process and facilitating composite applications and preserving the one application per container model. Whenever you deploy, the dependent applications definitely will be host shared, and it will make sure it will put the same resource in the same nodes. So it is co-locating helper process by natively. And also supports mounting many type of storage systems, that is volumes. So you can share the volumes from the host or Google Persistent Disk or AWS EBS Store, Azure File, NFS, iSCSI, and Cephas, many things. And also it distributing the secrets. And also it's maintaining the application health checking. And it will help you to replicate your application container instance across the clusters. And also it supports auto scaling. And the main important features, naming and discovery, your application instances will be resolved by DNS. And also it supports load balancing natively. And the main important features, rolling updates. Whenever you want to update your application instance, so it will take care of assembly with rolling update features. And also where you want to predict that how much resources actually used in every nodes. So it supports resource monitoring. And also it is allowed to access the logs and ingestions to many systems like AWS CloudWatch or Google Cloud log systems, etc. And also it supports easy debugging and introspection of your running application instances. And it's having a nice security features for identity and authorization. So we have seen about what is Kubernetes and what are the things. Now we are going to move it. What are the real concepts behind the Kubernetes? So there are many jargons I am going to throw to you. So please keep on listening because it will help you to move towards an hands-on. The first thing is cluster, the Kubernetes cluster. So Kubernetes cluster is nothing about as a cluster set of physical or virtual machines and other infrastructure resources which is used to run the Kubernetes binaries and your applications. So you can see the picture. So there are multi-nodes as forms the cluster. So one is going to act as a master and others are going to act as nodes. So nodes, what is nodes? Nodes, it's also called as a minion. So minion is nothing but a single physical or virtual machine running Kubernetes on which the pods can be scheduled. So this is the place where your application pods or containers are running it. And the most important common concept is called pod. This is a very, very important concept in Kubernetes. So pod is nothing but is a unit of deployment which you can apply across the Kubernetes cluster. A pod is nothing but a co-located group of containers and volumes. So it is the basic unit of deployment in Kubernetes. In what is called label. A label is nothing but a key value pair which you can apply to any resources. That means you can name, you can put a version on the pod, or you can put the version on the service. So you can easily put any identifications towards the resources. So a label is a key value pair that is attached to the resource such as pod to convey user defined attribute, identifying attribute. For example, name equal to order service, version equal to 1.0, like that. So label can be used to organize and to select subset of resources. How it is going to be selected? That the component is called selector. A selector is the concept. It's a selector is the expression that matches the labels in order to identify related resources. For example, if you see the left side, select resources where label key equal to label value. Suppose you want to select the resources based on some labels. Suppose I want to look all the pods which is running on production, or I want the pod which having a name called order service. So everything you can fetch via the selector. So the labels and selectors are very related, and you will see in action in hands-on lab. The other most important concept called replication controllers. So this is the state of art for managing the state of machines, state of pods, or state of containers. So what it does actually, so replication controls ensure that a specific number of pod replicas are running at any one time. For example, you want to run always 20 order pods. You want to run always, correct? So replication control will make sure always it's on 20 pods. Even if you kill one pod, automatically it will take care to run the same pod in any of the machines. So it both allows for easy scaling of replicated systems and handles recreation of pods when the machine it's on reboots or otherwise fails. So it will take care of that resiliency. So whenever the pods it's down or up by any events occurs, so it automatically maintains that state of what is the desired state you want to maintain in the cluster. The another important concept is called service. A service is nothing but an abstraction on to a set of parts. For example, so if you're running like order pods in across the machines. For example, the first pod is running in one machine, second pod is running on another machine, third pod is running on another machine, but all are service pods. Like for example, order service. So if that service you can select, you can call that service via using service cluster IPs or DNS. For example, I'm running my service to as a load balancer to point towards any of the pods which is running under the name of my service. So you can access the service via cluster IP or DNS. Definitely it will confuse you as of now, but while doing hands-on lab, you will easily understand. It is you can easily remember it's nothing but it's a load balancer. So whenever you want to like access one of the pods which is running across the cluster, it will access via DNS names or cluster IPs. So let's see the definition of service. A service defines a set of pods and names by which to access them, such as single stable IP, that is cluster IP, and corresponding DNS name. The next concept is volumes. So volume is nothing but is a directory, possibly with some data in it. So for example, whenever you see always the containers you might 90% you will run as a stateless, correct? But you want to maintain the configuration across that containers, or two containers want to access some data from the common location. So you need the volumes. So volume is a directory, possibly with some data in it, which is possible to a container as a part of its file system. Kubernetes volumes built upon Docker volumes, adding provisioning of the volume directory and of services. As I said previously, it's not only supporting that host volumes. So you can put the volume as a persistent volume as a AWS, EBS or GCE persistent volumes, or you can do Azure file, or you can put NFS like network file shares, or even iSCSI devices to share the volumes for that your pods. And the next concept is namespace. Namespace is nothing but it's a logical grouping of your resources. So it is nothing if you work on Java or C# or any other application languages, namespace is very familiar. So it can groups your resources. For example, I can put the namespace as production. I can put the namespace as sales pods. I can put the namespace as products. So namespace is like a prefix to the name of the resources. Namespaces help different projects, teams, or customers to share this cluster, such as by preventing name collision between unrelated teams. If you see the left hand side, you can see that two pods are running on sales.mypod. So here the sales is namespace. So then you can overlook that pods via your namespace, and also there in above you can see that there are two pods running on the products namespace. So if you want to access the product, only a products namespace, you can put the products.mypods. So it is a logical grouping of resources and providing that preventing name collision between unrelated items. The another important concept is secret. Secret is nothing but a secret stores sensitive data like username, password, or authentication tokens, or even SSH keys. It's like a vault. So you can, if you work with the AWS, you can have the AWS vault, key value stores, and many things you can, even Azure vault is there. So it's same thing like that. The Kubernetes natively provides a secret vaults to store your sensitive data, and which can be made available to your containers upon request. So for example, you want to access the username password to access some resources from the containers. So the sensitive secrets can be stored in the secrets. So Kubernetes natively supports the secrets. You can create the secrets, you can supply the secret to your pods, and so on. So you can easily understand while doing the hands-on lab. So be with me. The next important thing is Kubernetes architecture. So as we understand, there are many concepts we understand, correct? So in the previously cluster, node, pod, and label and selector, replication controllers, and service, and volumes, and namespace, and secrets. So why I have given this spec to understand this architecture. So, and here it's so much big, many complex components are built Kubernetes cluster. So don't worry about it. In the next slides, I'm going to explain it. But as of now, you understand. So Kubernetes cluster is nothing but, so you can have a master and a number of minions. So masters actually controlling the minions by master components, which is provided in the left side. So, and also in this picture, I put only one master, but don't worry, the high availability of masters also provided as of from 1.3 Kubernetes. So you can put it a high availability for masters also. But so now you understand the master contains many of the combination of components. So the most important component is called kubectls. The kubectl is nothing but it's a CLI which allows us to interact with any of the minions via the master nodes. So you can see that the kubectls is actually controlling the commands which is on the masters, and inside it's indirectly communicating to all the nodes. If you see, there is the main component called Kubernetes API. It's called APIs. So the kubectl always communicating your APIs, and inside the APIs commanding to your scheduler and control manager. So don't worry about that. You just hold the name. Again, we will come back that the real architecture, how it works after knowing each components. So you just keep in mind kubectl and Kubernetes API and scheduler and controllers, and you can see pod, services, replication controllers, which I already mentioned. And now you comes to that minions, that is called nodes. So I already explained. So each and every node, there is a component is running called Kubedns. It's an agent which is always keep on communicating to the master. And there is another component called proxy, which is allow us to communicate from the internet using the firewalls. So it is doing the port forwarding to the corresponding pods via the component called services. So we will understand that different names from the upcoming slides, but you understand now the components. So in the master, there is important component API, scheduler, and controller manager. And there is another important component called etcd. Etcd is the backing store for that entire cluster. So it maintains that every state of that entire cluster in the etcd store only. And this is the architecture. So we will understand the entire architecture while coming to the next upcoming slides, and again we will come back to connect the dots. So what are the main components of the Kubernetes, which I explained in the architecture? So now we are going to see one by one. The first, we will see the master components. What is called master components? Master components is nothing but the components which is going to install on the master nodes. And we are going to see the nodes components also. First, we will see the master components. The first components, which I already explained, called kube-apiserver and etcd and kube-control-manager and kube scheduler and add-ons and DNS and user interface and container resource monitoring. And the node components. What is called node components? Nothing but the components which is going to install on the nodes. The main important components, as I already explained, the kubelets, which is going to be installed in every minions. And also another components, very important component called kube proxy, which is allow us the service abstraction to kind of communicate to the outside world, and also internal clusters. And another important component is dockers. So docker is obviously it is the mechanism which to run the clusters, containers. So it's not only a docker is that the only container systems which can support by Kubernetes. Now the research is going on the another container systems called Rocket, which is from CoreOS. So that is in beta. It is also supporting. And there is another common called supervisor D, which is allow us to monitor each components for the resiliency and restarts. And Fluent D is actually allow us to ship the logs from kubelets to any other mechanisms. So now we are going to see each master components in detailed manner. The first component is very important component for the Kubernetes clusters called kube-apiserver. So this will be installed on the master node. So the kube-apiserver exposes the Kubernetes API. It is the front end of the Kubernetes control plan. So whatever the actions you are doing on master and any other minions, it is going to run by the kube-apiservers. It's intended to be a CRUD server with most all business logics implemented in separate components or in plugins. Whatever the actions you are doing in the cluster, it is going to done by the Kubernetes API. It mainly processes REST operations and validates them and updates the corresponding objects in etcd. The main thing is, so it is going to give a commands to all the components which is running in that cluster and going to persist that data in etcd. As I said, etcd is going to act as a Kubernetes backing store. So first of all, we will understand what is called etcd. So etcd is open source and also a distributed consistent key value store for shared configuration and service discovery. It's having nice features. You can compare this etcd to Zookeeper, a consular kind of any configuration management system. And you can see all the cluster data is stored here. This provides a great way to store configuration data reliably. With watch support, coordinating components can be notified very quickly of changes. So whenever the changes happening in any minions, suppose for example, one pod is down or one pod is up. So all the state is going to maintain in the etcd via kubelet services, and also it and your kube-apiserver is going to interact with the etcd only. So it is a center of truth where all the components is going to access, hey, what is my state? What are the data available for me? Everything is going to be etcd. You can see etcd is a database for Kubernetes. And here are the main important benefits of etcd. So it is very simple. and well-defined user-facing API. It's called gRPC. It's a Google RPC system. So all the interaction is happening in the RPC via RPC calls, which is built on the Go language. And also it is automatic TLS with optional client-side authentication. So it is very secure. All the functionalities is going on TLS calls, and you can write and reads 10,000 writes per second. It's a benchmark. It's very fast, excellent. So you can maintain the thousands of clusters using etcd. And also etcd, it's not required to be maintained as standalone cluster. So it can maintain that you can put the number of machines as a form that etcd clusters for high availability. And it's very reliable. So it is following properly distributed using Raft. Raft is actually a consistency algorithm. So it will apply on, suppose for example, you have multiple etcd. Suppose one is down, how that it is going to elect another as a leader. So that is going to use as a Raft, using a Raft algorithm. So if you wanted, you can go and see what is called Raft. It is nothing but it is going to apply the vote system across the nodes. So one is down, suppose your master is down, and how it is going to elect a new leader via the consistency voting system. That's what a Raft all about. And the main important thing is etcd is written in Go and use the Raft consensus algorithm to manage high available replicated logs. The another important component is Kube-control-manager. It is also going to be installed in that master. So it is nothing but as a binary that's run controllers, which are background threads that handle routine tasks in the cluster. Logically, each cluster is a separate process, but to reduce the number of moving pieces in the system, they are all compiled into the single binary and run in a single process. What do you mean by that? Kube controller actually acting in different process to control different mechanisms. For example, node controller. So node controller is responsible for noticing and responding when nodes goes down. So it understands that some of the minions are down. So how can I schedule? How can I command the scheduler to the file containers to other nodes that are actually is going to act as a node controller? And then as a replication controllers, it is responsible for maintaining the state of that desired configuration. That's very important aspects to maintain that. As I said, if you want to maintain, always run 20 pods for order services, 20 pods for sales services. So it is not going to run more than 20 or below than 20. It's always maintain the 20 pods across that cluster. That is handled by replication controller. And then the main another important controller is called endpoints controller. It is going to create the URLs and endpoints for services and pods. For example, now you are created a services, so you need to create that endpoints, because that endpoint is going to point to different nodes, different pods, different services, correct? So that is happening via the endpoints controller. Another important controller is called service account and token controllers. So service account, it's very important concepts in Google Container Engine or any other cloud ecosystem, because you want to interact from some client to control the clouds, and that you want to have the authentication mechanism or authorization mechanisms to maintain that secure transaction between your client and the clouds. Everything is happening via these controllers. So it is creating a default account API for the new spaces. So whenever you create it, so it understands what kind of a tokens, what kind of a service accounts needs to operate. Everything is controlled then. So, but logically these are that different controllers, but actually it's grouped in one single binary. That's what it is maintained. Logically, each controller is a separate process, but to reduce the number of moving pieces in the system, they are all compiled into a single binary and run in single process. So if you see Kube-control-manager, it will run as a single container in your master node. So you will not see that separate, but actually it is a separate background threads are running in logically and it's doing their work separately, but it is a single binary. So the next very important component is called kube scheduler. That is also is running in a master node. So what is that? So whenever you are commanding from the API, hey, I want to provision 20 pods or 30 pods. So this guy is only going to watch, hey, it's going to be newly created pods into the particular machine, or it's going to distribute that, it should be distributed across the machines. Everything will be taken care by this kube scheduler. So it watches a newly created pods that have no node assigned and selects the node for them to run. The scheduler binds unscheduled pods to nodes via the binding API. So the binding API will take care of it. There is a new node, but I want to run in any minion. So you can see that there is a scheduler which is running. Each want to select which node needs. It's a good guy to run the pod. So that's actually will act as going to check which resource is actually free and which is the better minion to act on it. Everything it will take care of this scheduler only. So very important component, you understand it. And another, the newly introduced component called Kubedns. So Kubedns it's a tool. It is not actually a component. It is going to run on Kube in a master. So actually it is currently in alpha, which is used to install secure Kubernetes on your machine and running on Ubuntu 16 or X onwards and CentOS 7X onwards and Hybridus OS 1.0 onwards. What does it mean by it? So Kubernetes, it's a guy who can provision your secure cluster in automated way by a single easy command. So actually it is doing so much things and also it supports your automation system in DevOps. For example, you want to provision the cluster using Jenkins. This is the guy you won't have to look for. So this process works well with local VMs, physical servers and or cloud servers. It's simple enough that you can easily integrate its use into your own automation like Terraform, Chef, Puppet, Jenkins, etc. And also, so Kubedns assumes you have a set of machines, virtuals or real machines that are up and running. So you have to provision your things and in advance. So it is going to install your clusters and the particular thing, and it's going to deploy initiate your master nodes, initiate your client nodes. All the things is going to happen via the Kubedns. And we are going to see in action because we are going to use Kubedns in all labs. So it is very important to understand. And it is designed to be a part of larger provisioning system or just for easy manual provisioning. So Kubedns is a great choice where you have your own infrastructure, example bare metal servers, or where you have existing orchestration system like Puppet that you have to integrate with. So it is simply you can say, hey, it is a command line which is going to automate your install kubelet server, install Kubernetes API, or install schedule. All the things is going to happen easily via Kubedns. So you don't require to manually pull the binaries from that things, and then you are going to install and you are going to configure, and then you are going to create your own tokens to communicate across the nodes. So everything will take care by ADMs. So and it is an alpha, but we have to be with Kubedns. Previously we have handled via all sh file, kube.sh files and all, but now we are moving to the Kubedns. It is a very upcoming tool which will do many automations across it. But the only problem is it is going to support with very new OS like Ubuntu 16x onwards, CentOS 7x onwards. But it is actually primarily everyone is using the CentOS 7, but might not be Ubuntu 16x, but it is going to be a rocking tool in future. The another important components which is going to be hot for that accessing the cluster via DNS names. So Kubedns is a very important component. It's going to give a DNS names to each and every resources, for example, pods and services on the cluster. And it configures the kubelets to tell individual containers to use the DNS service IPs and resolve DNS names. For example, I am going to give my service names is called my order service, correct? But my order services might split up to that across 100 containers, correct? So do I need to communicate via the individual IPs? No, you don't require to do that. So the kubedns is actually providing that DNS names for your services to access very simple manner. For example, you can access your services using my service, my order services.local, or my order services.sales, my order services.production. So like that, so it is going to distribute your request to that multiple pods via services as like a load balancer. For example, each services defined in the cluster, including the DNS service itself, is assigned to a DNS name. By default, a client pod's DNS search list will include the pod's own namespace and the cluster default domain. So as I explained, first we will see the example. So assume a service named customer service in the Kubernetes namespace called sales. So then you want to access the customer service. How you will do it? Either you just name it called http://customer svc. So automatically understand that how many pods which is running on the service and is going to distribute your request across the pods. And also you can, so these are naming conversion, or so you call as customer svc or customer svc.sales, that is your namespace as I said. Or you can state customer service.sales.svc.cluster.local, that is the default naming conversions, and you will get it. You can access that your services by DNS names. It is achieved by the component called kubedns, which is by natively running on your masters. So you can see that, and also it is running on 3 containers. The running Kubernetes DNS pod holds 3 containers. One is kubedns, which I already explained, and another is DNS mask, another is health checks called health. So health provides that health check endpoint while performing dual health checks for DNS mask in Kubernetes. Let me come back again. The kubedns process watches the Kubernetes master for changes in services endpoints and maintains in-memory lookup structures to service DNS requests. The DNS mask container, as I told, there is another container called DNS mask. Container adds DNS caching to improve performance. So that means kubedns container is going to act as authoritative name servers. DNS mask is going to act as a cache name servers, and another health container is going to act as a health check point, which performing dual health checks for DNS mask Kubernetes DNS. So it is very important to understand in previously you have to use your by name servers for resolving your DNS names or Sky DNS names, but now it is from 1.3 Kubernetes onwards. So it is supporting natively DNS called container DNS, a cluster DNS. So it provides natively DNS name resolution across the Kubernetes cluster. So that's what you have to understand it. And now we understand what are the components we have seen in that master. So again, I'm coming back. The first component, let me come back. The first component is called Kube-apiserver. That is very important servers for RESTful API service. The second component is called etcd, which is acting as a Kubernetes backing store to store all the state of the master entire cluster. The next component is kube-control-manager. It's controlling nodes, controlling replications, controlling endpoints, controlling the service and token service commands and tokens across the clusters. The another important component is called kube scheduler, which helps you to schedule the pods in on any of the minions which is available to us. The another important thing is KubeADM, which is the upcoming tool for the automatic provisioning for the clusters, for secured Kubernetes clusters, and it is our work for the configurations and running that containers in automatic manner. Everything is which will help you to automate the provisioning, and it helps you to easily integrate with the many DevOps tools like Terraform, Chef, Puppets, and Jenkins, etc. And another last component we have seen called kubedns, which helps you to resolve your service namespace, service pod namespace, everything. It can be done by kubedns. It is natively supports from 1.3 onwards. Now we are going to see the node components. What are the node components? What does it mean by node components? The components which is going to be in the every minion. The first and most important component is called kubelet. It's basically agent. It's a kubelet is the primary node agent. The kubelet manages pods and their containers, their images, their volumes, etc. So this is the guy is responsible for all the actions on the pods and services inside each node. So kubelet is the guy which is going to be sit in each node, and each kubelet is the responsible guy for in the pods which is running inside that his nodes. So he is a kind of a supervisor and a manager to manage their containers and their images and their volumes, etc. So he only understands that his own individual nodes. What are the functions of the kubelets? So as I said, it's watches for us that have been assigned to its node. He knows. So without his attention, no pods will be actually provisioned or run. So he is the guy who always watches for the pods. And also he only mounts that the volumes. For example, any EBS or host volumes or Azure files, everything is actually under control of his judiciary only. The third one is, so it's downloads the pod secrets. So as I said already, suppose your pods or containers have to access some of the resources which is very secured. That containers might depend on some secrets which is created by kubectls. So that guy actually these kubelets only can access your secrets and use it and run the pod containers via Docker. So kubelets is the only guy who can talk to that Dockers and then running the containers via Dockers. And also, so as I said already, Kubernetes is not only a guy for Dockers, but as of today, Docker is the only dominating the container system which fills that space of Kubernetes. But Kubernetes team also working on that Rocket, that is RKT from CoreOS. So they are also, the Kubernetes is going to support in future and already supporting in alpha and beta versions 0.5 onwards. So you can see the many articles regarding the rockets, but as I'm not going to cover that rocket in this labs, but in future I might put that labs on rockets. The next thing is, so it is the guy who always probing your containers. Hey, are you live? Are you died? Are you crashed? Or what is the state of that the containers? Are you going to spin up or restart it again? So this kind of all activities is watched by the kubelets. And the main important things, once you understand the things, this is the guy only reporting back to that master or back to the etcd. It's back to the Kubernetes API servers, everything. This guy is going to tell that, hey, my system is running these many pods and this is the state of the pods and I'm going and so my guy has died. Can you please reschedule it again? So these are the things are happening via this guy only. So and also it is the guy to understand this the status of the node. Hey, my memory is going down, or I am a crunch of like a CPU process, all the things, this is the guy only. But Kubedns is the guy, he is the only guy, but he, with the help of some other system called C-Advisor, but he's the guy primarily works on that, who is monitoring. C-Advisor actually basically monitoring your resources, but that Kubelet is going to communicate to C-Advisor, hey, what is my status of my machine? Because I want to report back to that Kube API servers, so he can make sure he will not overload me back. So that's things happening via the Kubelets. So this very important guy who is managing all the state of the system. So, and the beautiful thing is the another component called kube-proxy. So kube-proxy is nothing but, you can simply in terms call load balancer. So or he's the guy who is the front runner for internet world. So because as you see in architecture diagram, if you want to communicate to any of the nodes, you have to come via the kube-proxy. So kube-proxy enables the Kubernetes service abstraction by maintaining network rules on the host and performing connection forwarding. So he's a guy only going to check, hey, what these are the ports are actually open. So you are the guys actually can communicate with me. So those things, everything is done by kube-proxy. It's done by another component called services. So each node also run a simple network proxy and load balancer. As I told, it's called services. So the kube-proxy, you can simply in terms, you can call it as another name called services. This reflects the services as defined in the Kubernetes API on each node and can do simple TCP and UDP stream forwarding, round robin across a set of backends. As I told, so service is going to act as a load balancer kind of thing. Suppose I want to communicate, I want to get a service for order service. So I will hit the service IP or service DNS names. I will hit it, and then it will distribute my request to that one of the pods which is running under my name with the service names. So this is going to act as the actually stream forwarding for TCP and UDP streams. So for example, service endpoints currently found via DNS or through environment variables. So as I said, so for example, my service is name called my order service. Then I can communicate via my orders service dot sales, that with the namespace, or just my order service. And also another easy way to do that, suppose your one pod needs to communicate to another pod, how I am going to use it? Like for example, I want to communicate via some Node.js from Node.js, one Node.js services to another Node.js pod. For example, your UI pod want to communicate to the backend pod. So that time I will use environment variables in my programming. For example, I can use the environment, like for example, my service is called foo, and I can use that environment called foo underscore service underscore host, and then you want to port, understand foo underscore service port. For example, http:// and foo underscore service underscore host : foo underscore service underscore port. So that means I can access my other running services in any other nodes, which I can access via environment variables. So it is little confusing. It may little confusion for now, but while seeing the labs, while you are putting your hands dirty, that time you will understand how it is beautiful. So it is the most important component. It is helping us to resolve your ports and host managed by the service proxy. The very important for any business continuity, it's resource monitoring, is it? Because understanding how an application behaves when deployed is crucial to scaling the application, providing reliable service, correct? So suppose for example, I'm running number of pods in across the nodes, but how I am going to know what is my resource utilization is happening now, and I want to integrate with my monitoring systems like AWS CloudWatch. So I want to know that my system is in crunch, so I should not overload. What is the way to get the details? That's what the Heapster is coming to picture. The Heapster is nothing but a cluster-wide aggregator of monitoring and event data. Whatever is happening inside that regarding memory and CPU, so this is the guy is going to get the data. So, but he is the aggregator. Okay. So it currently supports Kubernetes natively and works on all Kubernetes setups. Heapster run as a pod in the cluster, similarly to how any Kubernetes application would run. So it is also a pod. The Heapster pod discovers all nodes in the cluster and queries usage information from the node's kubelets on the machine. The kubelets agent, correct? Then the kubelets itself fetches the data from cAdvisor. So as I said, so cAdvisor is the guy who is helping to get that usage information of the resources of the system. Then the kubelet is going to inform that, hey, these are the informations which I got from the cAdvisor. Please aggregate it with the Heapster. Heapster is the guy is aggregator, and cAdvisor is the underground guy who is really doing that resource monitoring. Then Heapster groups the information by pod along with the relevant labels. This data is then pushed to a configurable backend for storage and visualization. Currently supported backends include InfluxDB with the Grafana for visualization. So you can put that, you can see the visualization, and you can see that in a graphical way in Google Cloud or any other monitoring systems, you can easily achieve via this system. So Heapster is a very important guy who wants to do like aggregating all the monitoring and logging informations. And again, now we need to see what is called cAdvisor. cAdvisor is an open source container resource usage and performance analyzing agent. It is purpose built for containers and support Docker containers natively. In Kubernetes, cAdvisor is integrated into the kubelet binary. As I said, kubelet is the guy who is actually managing cAdvisor. cAdvisor auto discovers all containers in the machine and collects a CPU, memory, file system, and network usage statistics. cAdvisor also provides the overall machine usage by analyzing the root container on the machine. So you don't. So cAdvisor is giving that you can access the cAdvisor via 4194 port in the master. So what it does actually, it's not only individual containers. You can see the holistic information about the node. So what is that node CPU memory usage, as well as in container wise, each container how much memory and usage it is using it, what is the status of the file system and network usage, everything you can get via cAdvisor. So if you understand Heapster and cAdvisor and the kubelet, this combinations works well for larger cluster to understand that how I can get the reliable services by getting the information from these guys. So this also we will play how we are going to control that the provisioning via this details and all the things. So this is very advanced concept which is recently released with Kubernetes, that is also in like beta concepts. So if you see before coming to that, suppose if you take AWS or any other cloud, it's providing the cross region availability support, correct? So suppose if the primary region is down, it can support from that the another region, the secondary region, correct? So you can compare with this cluster federation. Nothing is so. Kubernetes cluster federation enables users to federate multiple clusters across different regions and cloud providers or on-premises installations into the single logical compute federation. For example, hey, I want to deploy the pods, but 50 pods has to go to the Azure, 50 pods has to go to that AWS, or 50 pods has to go to that my on-premises. So you can achieve via federations. So this is done by the cluster federation component. This is a separate binary, so it is not natively available with you. You have to use Hypercube binaries to download it, and you have to set it up. And I'm going to work with the lab for this also, so you will understand that. So when you need ultra availability, this is the guy you want to understand. So let's go to the definition. Cluster federation is useful when you want to deploy services across more than one cluster, region, or cloud provider. You may want to do this enable high availability, offer greater geographical coverage for your app, use more than one cloud provider, combine cloud providers, and on-premises solutions, or for ultra high scalability. The Kubernetes cluster federation system automatically deploys the service across multiple clusters in the federation, monitors the health of these services, and automatically manages the DNS records to ensure that clients are always directed to the closest, healthiest shots of the federated services. You understand? So every request, if you want to direct, hey, I want to nearby, I'm from Asia, so I want to near that, I want to access the nearby cloud. It's like a CDN kind of concept. So it's a traffic manager concept in Azure, and so you can whenever you access that, it is going to give the nearest nodes and nearest spots to you. So it is an awesome feature as per me, and it is recently launched, and still it is in development, and you can get more, I think, on that hands-on lab. Please stay with me. You will understand more things from this series of videos. So now you understand. So we already explored all the components inside that Kubernetes architecture, correct? So now you understand. Now the guy called kubectl, that is a CLI command, which is going to give the commands to your API server. As we explained, API is nothing but is a RESTful API which can control all kind of activities across the cluster. So and also natively it controls pods, services, and replication controllers and all things. That's it. And also, and API is going to command to the scheduling activator, to the scheduler. The scheduler, what it does actually, hey, okay, so I got the command from that API servers, so I need to schedule two more pods into that one of the minions. That's what actually it does. The scheduler is calling that pods, taking the pods and deploying to one of the minion via kubelets. Correct? So as I told, kubelet is the guy who is the master and supervisor for entire individual nodes. So whatever the commands he's getting from the scheduler, he's going to do that. And the another thing is the controller manager, correct? As I said, controller manager is a single binary, but that will handles many type of controlling. As I told, node controller and replication controller and token and service account controller, everything is handled by this control manager, correct? And as I said, entire state of the data is going to store in the etcd, correct? Because a kubelet is going to take this information from any from that individual parts and going to tell that, hey, this is the state of my system, and is going to store into that distributed watchable storage called etcd, correct? And eventually they are going to support different key value stores like Zookeeper and all, but as of now, this is the guy who have to put your eyes on this. And as I told, kubelets always communicating to the C advisor for utilization of resources like memory, CPU, network, and file systems. All things handled by the C advisor and going to communicate to kubelet, and kubelet is going to communicate to the Heapster aggregator, and that the Heapster aggregator you can give that connection to CloudWatch or Remain or any monitoring tools. You can use it. And another important, very important guy is called Dockers. So the Docker is actually use the runtime for the containers. And today, actually, the only guy supports by Kubernetes for production. Sorry, Docker's Kubernetes in production for Dockers. But in future, they are working on the Rocket. It's already in beta 0.5. Kubernetes supports that Rocket implementation as a containers also. So we understand the main important kubectl APIs and scheduler and controller manager and pods and etcd and kubelet and proxy and dockers. So as I said, proxy is the guy who is actually doing service abstraction and distributing the load to that pods, and also is the guy who is actually handling the firewalls for the host to actually for port forwarding for UDP and TCP, and then it is handling the security also. So these are the main important concepts behind that Kubernetes. That's all for this session regarding Kubernetes introduction. Thanks for watching. It's much appreciated. I know I took more time to explain this Kubernetes ecosystems, but actually it is not avoidable because it contains more complex components and concepts. That's why I took more time. Anyway, thanks for watching, much appreciated. And further, I'm going to do more workshop sessions which to explain everything is in production ready hands-on labs. So please stay tuned. And if you want to access the source code, please go to my GitHub repository called github.com/nityananda/kubex. And also please sign up for my newsletter. And if you have any suggestions or doubts, please send me the mail to info@nitya.org. I am happy to assist you or happy to receive your feedback. Thanks for watching. Have a great day. Bye.